Hi, everyone, and welcome to today's Move webinar. We've got a really exciting lineup of heavyweights in this area today for you, and we're going to kick off now in just a moment. Just wanted to mention that we're going to have an open Q&A about 20 minutes from the end, so that's in about 40 minutes time. We also have some very exciting webinars coming up, more about them shortly, but without any further ado, I'm just going to hand you over to your host for today. That's Andrew Grant from BloombergNEF. Andrew.
Thanks, Cormac. First, I just need to say the Move event in London that we had in February was one of the best conferences I've been to. And it's wonderful to be able to continue the types of discussions we were having there, albeit in a slightly different format. So thank you to everyone for joining us. My name is Andrew Grant. I'm a transportation analyst with BloombergNEF. So that's Bloomberg's primary research service. Today, we'll be discussing the many routes to cleaner transportation and how important vehicle segment is in determining in deciding which drivetrain will power a vehicle. So as Cormac mentioned, we'll be taking some questions a little bit throughout, but also we'll save some time at the end. So please use the Q&A function in the browser. But first, let me introduce my panel. First up, we have Avinash Rugoobur, the Chief Strategy Officer from Arrival. Avinash is a veteran of General Motors, where he led advanced technology activities at GM's Silicon Valley office, including the $1 billion acquisition of autonomous vehicle company Cruise Automation. Arrival itself produces electric vans and light trucks, and just a few hours ago, they announced they would begin producing electric buses. We also have Pettersson, Head of Sustainability and Public Affairs at Scania. Scania produce trucks, buses, and coaches, and the engines for a variety of other vehicles. Also has previously worked at Swedish energy company Vattenfall, so is expertly positioned to address how transport and the power sector can work together. We also have Johnny Goldstone, the co-founder and CEO of Green Tomato Cars. If you've seen a hydrogen-powered Toyota Mirai around London, the odds are pretty good that it's a green tomato car. The company's been working with a fleet of 50 fuel cell vehicles since mid-2018. And the private hire vehicle company also has electric, hybrid, and combustion engine vehicles on the platform. And then last but certainly not least, we have Peter Harris, the International Sustainability Director for UPS. Peter's had numerous positions within UPS, ranging from Automotive Director to Industrial Engineering Director to Sustainability Director. So already with more than 10,000 vehicles of the 130,000 UPS vehicle fleet powered by electricity, alternative fuels, or good old-fashioned pedal power, there's a lot more to come. So in January, UPS announced it would be purchasing 10,000 electric vans from Avinash and Arrival. So perhaps to get us started, Johnny, if I can throw to you with a question. So at the start of 2020, there were 17,000 passenger fuel cell vehicles by our count globally, compared to nearly 7 million plug-in hybrid and battery electric passenger vehicles and tens of millions of petrol and diesel vehicles. What was it about fuel cell vehicles that made you decide to include them in your business?
So thanks, Andrew. For us as a private hire operator, we have two models for our drivers. Some are employed and some are self-employed. And what is critical for us as a business to have a commercial model that is successful is that whilst being as low emission as possible, which is our founding principle as a business, the drivers have to be able to use a vehicle that they can fuel or charge quickly and that has a significant range to enable them to do an average of 100 to 150 miles in a day. So those two factors from an operational perspective for us put hydrogen ahead of pure battery electric vehicles, given where we operate. Clearly, if we were somewhere else and there is no hydrogen refueling infrastructure, we wouldn't have chosen those vehicles. But there is a sufficient infrastructure around the London and Greater London area for us to be able to operate those vehicles. 3 to 4 minute refuel. We're getting over 300 miles range per full tank now. And that obviously is a significant improvement in terms of speed of charge and range compared to the electric vehicles that are on the market at the moment.
Great. Avinash, I want to talk a bit about the bus as well, but first off, I want to talk about how you saw a gap in the market for an electric van / light commercial vehicle. And
yeah, sure. So if you look at the commercial vehicle segment, it's traditionally been underserved by the traditional OEMs, I would say. So, typically what's been happening is there's a vehicle architecture that's, 10 to 20 years old, and you've got the diesel or fossil fuel powertrain in the front, and even when you're going electric, you're taking that out and you're just basically electrifying it. So you end up with a compromised vehicle on multiple fronts. One is there's a cost premium for going electric. So, you're just adding a battery to an architecture that's not designed for it. That's what makes typically electric vehicles a little bit more expensive, quite a bit more expensive than fossil fuel ones. But also, you're not getting any benefit from going electric in terms of the way the commercial vehicle partners such as UPS need to use the vehicles. And that's particularly when you think of cargo efficiency and you think of payload to gross vehicle weight. So for us, going electric was important in the commercial vehicle segment because when you have this fully flat floor as per a skateboard structure, and in your rival's case, everything, including the drivetrain, is all packaged within that skateboard. So there's no top or rear bump or anything like that. It's fully flat. You end up with greater cargo efficiency for a vehicle of the same size, up to 40% in some cases. And also the payload. And so we've got a 4-ton van that's got a 2-ton payload. And it's best in class. So you have none of the compromises. But then, of course, you help cities hit the zero emission targets. I mean, obviously, in London, it's particularly important with the ULEV zone. But also, the way we've built the vehicle architecture is such that with the modular architecture that we've built, which we can go into more detail, it enables us to move from electrification or fuel cell or whatever future technologies come that are the best for the use case.
Yeah, and then as you scale up these commercial vehicles, you run into a few other different challenges. So I'm going to throw to Asa here and say, with heavier commercial vehicles, how far along they are on the road to electrification, and what are the unique challenges there?
Yeah, so we just announced the electric bus, as you mentioned, a few hours ago. So Arrival, using the same technology, again, it's this idea of modular architecture. It can translate to any vehicle. So, it's a portfolio of solutions that really what we're trying to do is create an integrated transportation ecosystem. So bus is the one that we're announcing today that will be using the same battery technology and software systems architecture that we use in the van, translated over to the bus. With the bus's size, we obviously can lay out more batteries and you get greater range. So it does translate. And then, as mentioned, if you go smaller, that also works as well. And it really comes down into how you really think of the vehicle architecture and the way you want to package the systems. But also when you go to, for instance, 6-ton, 18-ton, 20-ton trucks, then you can have open discussion about, okay, we can package fuel cell. As the fuel cell tanks start to get more efficient in size, you can also go down. So I really think it's a pretty open playground. And we're thinking about this as a platform that, depends on what's the best power source, we'll put it in. We just know that we want to be clean and green. So we're staying away from sort of traditional fossil fuel ones.
Yeah, also Avinash has teed you up there. Anything to add on heavier commercial vehicles?
Thank you so much, Andrew. Yeah, I mean, since we belong to the traditional OEMs, of course, we've been looking at this major shift of electrification for some time already. And we have the benefit of being very close to our customers and developing the solutions together with them. And as clearly pointed out, yes, I mean, it's all about business case and knowing when this transition has a positive break even, basically. But what we see now is that this is happening very, very fast, and that the cost of batteries is going down at a very fast level. And we can see cost parity in several applications that we are developing right now, as close as in 2 or 3 years away in certain markets. So and the clear benefit of running on electricity in every case is, of course, the price compared to diesel. That is the major driver in this shift. So matter if you're constructing a vehicle from scratch and designing an electrical van or truck, or as we as incumbents are trying to adapt our technology as we run our current solutions, there are benefits in that as well, of course. The major driver is really the diesel price compared to the electricity price, even including the cost of infrastructure that, of course, in the beginning will be higher because you need an infrastructure. We don't have this infrastructure currently, so we need to build the infrastructure. But even including that, and over time, it is a much cheaper system to run on electricity overall. And there we see, of course, a clear benefit from our customers. But you need to find this balance. I mean, today, if you carry heavy batteries, that comes at the price of not being able to carry as much cargo, for example, of course. But this is under development, and of course it depends also on which charging infrastructure you choose and how you choose to operate both the longer distance, long haulage vehicles and the shorter distances for local and regional distributions. And we see that there can be possibly different charging infrastructure systems in place to address all of these different needs.
Great, and there's a number of points there that I want to come back to around charging infrastructure, and we've mentioned ecosystems a few times. But first, I want to get Peter's thoughts. From the UPS perspective, what's the low-hanging fruit in terms of electrification? You deal with a number of different transport modes. What are you attacking first?
Yeah, thanks, Andrew, and good afternoon, everybody. So just a bit of context on that question. So we're a global logistics company. We move things around the planet. That's what we do. And there are really two pieces to our operation. There's the urban collection and delivery piece. So those are the collection and delivery vans, 3.5, 7.5 ton, that sort of size, running around cities, doing multi-drop operations during the daytime. And then overnight, there's the heavy long-haul 38, 44 ton tractor, semi-trailer type vehicles running up and down the motorways, connecting the cities together for the next day's deliveries. So if you look at those two types, it's very much the former. It's the urban collection and delivery vehicles that are suitable for electrification now. And we've been going down that road for a little while, probably about 10 years now in some shape or form. To Avinash's point, we had to start, because of the lack of availability of product, we had to start with taking our existing diesel fleet and developing conversion solutions with partners to convert those vehicles from diesel to electric at their midlife point, which had the advantage of allowing us to learn about the complexities, but the disadvantage that it was expensive and they remain non-optimized, as Avinash has said. We're now entering a world, of course, where in conjunction with partners like Arrival, it's terrific that we've got entrepreneurial organizations like Arrival that are coming to the fore. We've been delighted to invest in and partner with Arrival to develop a brand new concept of urban distribution vehicle. Really looking forward to getting those on the road because that brings all the advantages that Avinash has been talking about of a clean sheet design. So, yeah, we already have, as you said, 10,000 alternative technology vehicles on the road now out of our 130,000 fleet. We have some ambitious goals, and the deal with Arrival for 10,000 new EVs is a big part of the way forward on that. So, but the answer is very much in that urban collection and delivery piece of the operation. And yeah, when we come back to charging infrastructure, maybe a bit later on, I'll kind of talk about some of the challenges that exist there, because it's really not all about the truck. It's also very much about how do you get the power to the truck, and that's a whole new dimension to the challenge.
Yeah, the challenges on both sides, improving the vehicle and then expanding the charging and the refueling infrastructure. Johnny, there's a question that's come in already on the chat around how widely available the hydrogen refueling infrastructure is, and if you expect that to increase, and then I guess who ends up owning and paying for that infrastructure.
So in terms of availability, I don't want to be too London-centric, but that's probably, if I have an area of expertise, that would be where it is. I believe there are certainly countries and parts of countries with a much greater infrastructure than we have in the UK at the moment. In and around London, there are 6 refueling stations, and we had to decide based on quite closely based on where our journeys start and end, and where our drivers live. That was part of our decision in terms of the viability. So, it's clearly nothing like petrol stations or even EV charging points. Who owns that infrastructure? I don't know that I care particularly, as long as it works. I don't really care who owns the petrol station infrastructure, or at least I didn't when I was going around in a car that needed a petrol station. What matters to me is that it works and that the fuel is available at a good commercial price, quite frankly. Whoever's going to do the best job of that should own it, as far as I'm concerned.
But from a business model perspective, you need something slightly different from what, say, a wider passenger vehicle fleet would need, right? You would need refueling infrastructure in specific locations, and that suit the transportation network. And then on the electric vehicle side, you'd also need charging infrastructure that is, say, higher powered and positioned optimally for your drivers.
Yes. So, I mean, if all the refueling stations were clustered in a part of Greater London that we very rarely go to, then it wouldn't be viable for us. As it is, there are a couple out near Heathrow where pre-COVID 20% of our journeys would start or end at Heathrow, and so on. And we're also, like I said, able to choose drivers who live relatively close to refueling stations to be those drivers who go in those cars. We've looked at the battery electric vehicle option a huge amount, and we keep coming back to it. We don't think it's hydrogen or battery. We think it's or plug-in rather. We think it's both. The fundamental issue for us there is that there is not currently the overcommitment and over availability of rapid or fast refuel recharging stations in a sort of hub context that I think would work for our use case. So the vehicle itself, we're currently only using the Toyota Mirai, and that is more than suitable for the job. Especially the new model that's going to come out will have room for 3 passengers in the back rather than the current model for 2. Actually, in COVID, only being able to fit 2 passengers in the back of a car isn't a problem anyway. But yeah, the refueling or recharging requirements for our model are very much bespoke to a high mileage urban context, which clearly a lot of use cases wouldn't have, but private hire and taxi does have.
Right. Avinash, a big part of your business model is vertical integration. How does charging infrastructure feature in that plan? Yeah,
so as you mentioned, we think about the vehicle as a system and an ecosystem. So particularly when you're focused on commercial vehicles, as we've begun, we are looking at what are the major pain points for our customers. So it's not just one thing to say, okay, here's the electric vehicle, that solves the price point, it solves some of the things I mentioned already in terms of cargo efficiency and payload. But then you have to really think about what do you do on the infrastructure. So on that side, we actually use a lot of our technologies again and repackage them into battery storage and also into charging infrastructure solutions. So that's something that we'll be rolling out over time. And the point is, again, to use the sort of scale that we'll have to help reduce the charging infrastructure cost. When it's focused on a depot, it's a much more straightforward problem to solve because you upgrade one depot. As we move out into charging stations in terms of being for retail vehicles that are distributed everywhere, we'll be looking at other unique solutions to get into that. So I do think depending on the region as well that we go into, you have to think about the grid. So you have to think about energy storage, the cost of upgrading the grid in some cases. So being very strategic in terms of where those depots need to be placed, which ones are upgraded. And then that brings us to the other part of the ecosystem, which is all of the connectivity and digital tools that sit on top of the vehicles and the charging infrastructure. That is all basically about how do you optimize the fleet, when should you charge, how long should you charge for? And the more data we get and the more sort of connected the vehicle is, the better we're able to optimize that for people like UPS. So it's not a one problem to solve. It's actually how do you create this transportation ecosystem that really serves the needs. So you have to look at all of those touch points. I mean, we even take that even to the design of the van. Like we have some pretty unique technologies, even the way we think about how drivers and delivery folks deliver packages and have to get in and out of the vehicle, and how do you do actually the door opening, because even that level of user experience can be a problem. So we think down to like that level. So if you imagine that across vertical integration, we look at the experience and every touch point and how do we optimize around it.
And when we've spoken in the past, you've mentioned also some of how that affects the retail side of things. So if you are selling all these vehicles to customers, or if you end up leasing them, or if you end up kind of leasing them and including charging infrastructure and including including charging in the price of the vehicle, how does that, or what portion of that is your plans going forward?
Yeah, it's a really interesting thing when you look at electric and you look at the total cost of operations. Some of the other sort of unique innovations we bring into the market is our sustainable materials, which so everything for the upper body, they're all a composite material that we've developed in-house. So that removes the need for sort of metal stamping and paint shops, and you know, we can even do in mold coloring of our panels. So that really brings the cost down. So when you look at the overall outlay, you have the initial purchase price, but then you obviously have the total cost of operation, which, as Asa mentioned, includes the cost of the actual energy, but it also includes the repairing and maintenance and the charging infrastructure that you have to lay down. But when you have an electric vehicle that's priced the same as a diesel equivalent, and you have a total cost of operation that's getting to around 50% of what it would be if it was a traditional vehicle, you start to get to some really unique business models. Like, as you mentioned, being able to lease a vehicle which includes the infrastructure as part of that cost, or includes the connectivity services as part of that cost. And we take a very open approach with our customers. Even, for example, on the bus, there'll be some markets where TCO model, the total cost of ownership model, will be a better way of introducing it to the market than the operator buying the bus and sort of as a capital purchase. So we're very open to that, and it's definitely factors into each different product will have sort of a inflection point as to whether or not it's a purchase model or a leasing model.
Yeah. And then also, like, as you scale up these vehicles and you get to much larger vehicle sizes, you end up with really huge batteries, so or fuel tanks. How do these numbers work out for you?
Yeah, I mean, I agree with the analysis made here by Peter. I mean, this is going to happen first in the urban areas, and it's happening now. So then it will be like Avinash was also into. I mean, the business models around the charging infrastructure, they're very important. We're putting 75 battery electric vehicles, trucks for regional and urban distribution in Norway on the market this year. And of course, there we need to build the infrastructure together with partners. And business models connected to that are extremely interesting, where we also look into exactly these TCO models, where we have applied since long that we sell per kilometer, and with the whole total service and repair and maintenance, and of course this will now have to be applied into this new landscape. All trucks that we put out on the market already today are connected. So we can see data from all our trucks moving globally around the world. Today we have more than 400,000 vehicles in operation around the world with our customers, which gives us a very good overview of where this infrastructure needs to be built, actually. We can see exactly where vehicles stop and rest and for how long. And this will, of course, be the natural points then to focus the charging infrastructure. In these urban deliveries to begin with, and local and regional going in and out of cities, it's very natural to start with overnight and depot charging, and also charging while loading and offloading. But you need also a completing charging point somewhere along the roads. And then it's very natural to look at where the trucks stop anyway. You know, you have these driving and resting times that regulates how many hours you can drive, which is 4 hours, and then you need to stop for 45 minutes. So it's very natural to follow these patterns and movements of the vehicles that we can very clearly see then in our data already, which is very useful when developing this going forward. And then when you look into the more long haul operations, then these questions really come into place. Then how much batteries are you going to carry? How heavy are you prepared to load your truck? And then you have the option of dynamic charging that is also very interesting to explore, to charge your vehicle while driving, which will also give a less heavy effect on the electricity infrastructure, because that's regarding long haulage. If take this example again with driving and resting times, but if all trucks stop at the same time to charge for 45 minutes, the impact on the electrical grid will be hard to cope with, unless you then make also some kind of investment into the electrical grids. And here dynamic charging can be a very interesting option. We've been running pilots both in Sweden, and we are running pilots in Germany on this. And that has positive effects both then on the amount of batteries that you carry with you and on the impact on the electrical grids. That's of course then also an option that hydrogen can solve, where you don't have to carry as much batteries with you as well. So these are very interesting choices we need to make ahead in Europe as well as globally. Which charging infrastructure and how is this going to develop? So we need to take these decisions now together.
A big part of that, as you mentioned, was collecting as much data and getting a real understanding of how these vehicles operate and where they move and when they move. Peter, I imagine in UPS there's a pretty good understanding of where all the vehicles are at all times, and the packages and everything on top of that. But the vehicles themselves, I imagine you've got a pretty clear idea about how to extract the most value out of those vehicles. So what do you need from a charging infrastructure or a refueling infrastructure perspective?
Yeah, thanks, Andrea. Well, indeed, we do have pretty good telematics data information systems that give us the required information to help make those decisions. So it's interesting when you start looking at infrastructure. The nature of our urban collection and delivery operation that we were discussing earlier as being suitable for electrification, the nature of that operation is that it operates on a back-to-base basis. So the vehicles are all out during the day, and they're doing multi-drop work. They don't really stop for long enough for any form of on-road charging to be feasible, but they are back at base overnight for a significant period of time. So that leads us towards a back at base in-building, in-depot recharging solution. And that has advantages and disadvantages. The advantages, we know where the vehicles are, and we can manage that. The disadvantage is that you're then placing quite a heavy demand on individual buildings in terms of energy supply that building may well not have been designed for. If it's a legacy building, and pre the day of any form of fleet electrification. So that takes you into the world of, you find yourself in the world of grid upgrades, which some of the panelists already mentioned. That's a pretty ugly process, to be honest. Our experience there has been that the whole grid upgrade process and working with the distribution network operators, it's expensive, it's inflexible, it's really designed for industrial estate type upgrades rather than the individual buildings aiming to electrify their fleets. You end up finding yourself having to invest in assets that you do not own. Because the end user takes responsibility for all of the costs associated with upstream upgrades, even if they're outside their own fence line. And it's inflexible. You can't take the upgrades with you if you choose to change buildings. So there are two ways forward there that we think are important. One is that government needs to look at that infrastructure upgrade market, and we need to ask ourselves the question, does it really make sense for the end user to bear all of those upstream costs, because that just acts as a massive disincentive for fleet electrification. We think there are better models that can step in there. And the other part of the solution is technology. We formed a consortium a couple of years ago with the network operator in London, UK Power Networks, and also their market-facing services arm and crossover partnership. And we got some funding from Innovate UK, and we developed the world's first combined fleet-scale smart grid and energy storage solution that had the effect of quadrupling the number of vehicles that we could charge in our central London operation without any further grid upgrades. So technology is a big piece of the pie, and there's without a doubt room for a lot of market innovation in the provision of those technologies to end users who are, for the most part, just looking for a simple system. They don't. Most operators don't really want the hassle or have the capability of getting into the engineering of all of this stuff. They just want to be able to buy a truck and operate it. So there's policy areas that are needed, and there's technology innovation and market innovation areas that are needed. And just quickly on the long haul, when we start to move into the out of urban distribution and onto what's going on with the long haul, I agree with Asa that dynamic charging probably has a very strong future. I can see a positive future for catenary-based on-road charging, so the provision of electricity to maybe the inside lane of motorways, much like we would do at the moment with trains. That would be an efficient way of providing a solution. But I think we also need bridging solutions that will get us there. So we're very much in favor as an organization of renewable natural gas, which is it's just like compressed natural gas or liquefied natural gas, but it's made from organic waste, very low carbon footprint, and a good bridging solution for maybe the next decade or so as we develop these electrified alternatives that will take us into the long-term future.
I throw it back to Asa here, please, because LNG and compressed natural gas, how do you see that fitting into the near to mid-term?
Yeah, definitely. I mean, taking it from the transition perspective, I mean, which solutions can be applied when, even if electric trucks and electric transportation is developing very fast for the moment, it will take some time before this can really contribute to reducing CO2 emissions in any greater extent. And in the meantime, I mean, taking into account that it will take some years before we have the infrastructure in place to have the amount of vehicles out there that will really make a contribution, I totally agree with Peter that bio LNG or biogas based LNG is a very, very interesting bridging solution. As a matter of fact, Scania has today already the largest range of combustion engines that can already run on all available commercially available biofuels. So both sustainably produced biodiesel, sustainably produced bioethanol, and sustainably produced biogas are interesting alternatives because you can apply them already to the current infrastructure and the rolling fleet, which means you get an instant CO2 reduction here and now, which is totally necessary. And we see this is a very interesting option, and we definitely push for an increased production of all of these fuels, especially since they will be needed for other forms of transport like aviation and shipping that will not be able to electrify at the same pace as we will be in heavy duty transport. So definitely that's a very interesting option going forward, or here and now, I should say, not even going forward.
Yeah, but to some degree, it's dependent on the market that you're selling into as well. So there's going to be a number of there's going to be a lot of differences across regions. Avinash, you've got micro factories that you want to set up in various different parts of the globe. What do you look for in a market when you are looking to set up there?
Yeah, it's a great question. So just probably a little bit of context on the micro factories that we've pioneered for our manufacturing process. These are 10,000 square meter factories, very low capex. So we're already having a lot of discussion with a lot of governments about bringing those factories to regions around the world, because obviously it brings manufacturing to the local environment. You pay local taxes, you help support the local supply chain and job network and talent. So when we think about a market, we're looking at, obviously you're going to look at, we tend to think that if a vehicle is the same price as a traditional vehicle, if an electric vehicle is the same price as a traditional vehicle, you've basically created the paradigm shift, the inflection point for everybody to move to electric. And so we don't necessarily look at the size or the penetration of electric vehicles within a market. We actually look at what's the actual total car park, and that could be, broken down into segments. But the way we look at it is when we're talking to local partners and local government, we're seeing what type of vehicles matter to certain regions. So, we announced the bus today, but there are certain regions that actually travel in minibuses. And so, with our architecture, we explore, well, what does that mean if we turned, like the van platform into something like that? And so for us, we try to maintain an approach which is, use the technology pieces that we have, like the Lego blocks, to build different types of vehicles for different use cases. So they're very much tailor-made to what the local supply chain can provide, what the local region needs, right? So different cities need different things. And that's really a key part of some of the value that we bring. So the bus we announced today will take different forms in different markets based on what they need. And so I think it's a critical point. So for us, it's really, dense urban environments. We'll start looking at a portfolio solution that's, smaller type vehicles. Then you have, wide urban environments where you might be able to have larger vehicles in that. So again, it's a portfolio for us.
So, I mean, what has been a biggest selling point in your discussions with cities? The fact that it's a clean electric bus, or this ability to set up locally and do some local employment and customize it for the local needs?
Yeah, it's been a few things. It's been no real reliance on government subsidies. So a lot of governments are having to obviously subsidize this transition to electric. So when you're at the same price point, you can move away from those. So it really helps to sort of bring the reliance on government, sort of kickstarting that away. Definitely the local manufacturing. I mean, this situation we find ourselves in with COVID has also brought to fore like the ability for, down to the city level to be able to have their own sort of manufacturing capability. And of course, being able to do local talent that's designing, vehicles that meet the local requirements, and also the nuance that you find in different cities and urban environments.
Yeah, and we're really talking about that first point that Peter mentioned about policy, but also pleasing different stakeholders so that everybody gets something out of the deal. Johnny, from your perspective, if you want more refueling infrastructure, who are the stakeholders that you need to get involved to make that happen, and how do you go about doing that?
So the key stakeholders, I guess, as we see it, are the manufacturers themselves, the fuel suppliers, the people who are operating those refueling stations. That's in the commercial ecosystem that we operate in, and also the people who have the land that those refueling stations are going to be put on. And then clearly there's all the planning side of things that is going to be critical in the decision for a refueling station to go anywhere. I think to be candid, we are the smallest player with the end user in this context, and so there are much bigger fish swimming in the pond who have the clout from a political perspective and also from a financial perspective. But that in itself is a fascinating part of this, especially if you see it as early adoption technology, that a relatively small business like ourselves, which is 15 to 20 million revenue, is as critical to the uptake of certainly the vehicles we're using as the likes of large players like Toyota, Shell, other operators that are critical in this whole piece, as well as government bodies and funding agencies. So that makes it very interesting and helps us punch above our weight to be part of a consortium approach, without which I don't think it would have got off the ground from a passenger vehicle standpoint, really, because we wouldn't have bought the cars if we didn't know that the refueling infrastructure was going to be there. And Toyota wouldn't have brought the cars over if they didn't have someone who was going to buy them. And the refueling stations wouldn't have put in the huge cost of getting built if they didn't think there was going to be someone there. So the chicken and egg sort of in multiple directions has been pretty successfully, from our experience, addressed by taking on a consortium approach. I don't know how similar that is for the other panelists in their position in this model, but certainly for us, being a small fish in a big pond, but all swimming in the same direction, has been, really pretty crucial.
Yeah, I'll throw that to Asa. You've mentioned a bit about ecosystems and charging infrastructure, meeting vehicle improvements. What do you think?
I think that's a very important aspect, and even if we are a large OEM that's been for a long time on the market, we definitely need to cooperate. There are so many, actually new players in this landscape. So it's not only the traditional infrastructure suppliers or electricity companies. There are so many new players, and also taking into account connectivity and digitalization and all the data with which we can improve the use case for our customers. So this is the new ecosystem that we're talking about and that we're looking into, and it's extremely important for us to work in partnerships and then to find the business models that work for all of us, including our customers, in making this change together.
And as these supply chains and different component manufacturers have developed technologies at different speeds, it's become as that's happened, and then we've run into COVID-19 regulations and lockdowns and the effect of that on the automotive supply industry. How do you see that's changed the rate of electrification, the rate of development of new technologies?
No, that's a very, very good question. We're an industry in crisis and have been now. We had to close down our production completely during 2 full months, March and April. And we're now coming back to full production again, but large parts of the companies, of our company, and as well our peers in the industry are still on short-term leave. Or short-term work. So, but actually one of the areas that we've been working on full time during this difficult period is electrification, and to continue to develop our products with regards to electrification. And that is for several reasons. One, we need to see this happening. Scania announced also in the middle of this crisis that we have set a science-based target, also including, which means the user phase of our products when our customers use them. And for us to be able to achieve it is absolutely necessary to make this shift towards electrification. So in the longer term, what we see is that an increased use of, as I said, biofuels is very important in the short term, but in the longer term, we see that electrification will be the solution for heavy duty transport. So that's why we have continued to go full speed ahead on that. But our supplier network, just as you rightly mentioned, that was the reason why we had to close down production completely. It was completely, with all the lockdowns, we could no longer get any components through to our factories. So this is an important discussion going forward in this global value chain that we are in the automotive industry been working with so successfully for so many years. We will see probably a regionalization and a more concentration then of critical parts. We already see that, and that trend was already there regarding battery production, where Europe is really is looking upon that as a strategic asset going forward, and setting up several production sites regionally and locally in Europe. So this is really a strategic choice for Europe going forward.
Okay. Peter, from your perspective, in terms of your electrification projects and other innovation projects, how has COVID-19 in the last few months affected that?
Yeah, so the COVID crisis has changed the nature of our business in that we've seen a dramatic swing towards what we call B2C e-commerce, and more people shopping and shipping online. So our mix has changed significantly. But I wouldn't say it's had a substantial effect on our sustainability or alternative fuel strategies. They're very much more part of the longer term vision. So they're proceeding anyway because it's important that they do. And I just want to make a point, if I could, just going back on the concept of partnerships that we were discussing earlier. I completely agree with everything that the panelists have said, and I mentioned the partnership approach that we took to the smart grid development. And I think what's going on here is that actually we're almost seeing a shift beyond partnerships into a form of synergy now that's taking place between sectors that used to be in almost separate industrial silos. So if you look at what were separate transport and energy sectors, they're coming together now in a way that they're just becoming mutually dependent and able to provide solutions to each other's problems. So, for example, the energy sector providing technology solutions to the types of charging infrastructure challenges that I mentioned that we had as a transport operator, but in vice versa, you can see a world approaching where fleet batteries in EVs in fleets such as ours provide bulk energy storage solutions that allow grid buffering opportunities at times when the grid is under stress due to maybe the wind's not blowing or the sun's not shining and the grid needs to be balanced. So that synergy between the two sectors, I think, will be really fascinating development going forwards, and one that we've only just begun to scratch the surface of in understanding.
Yeah, I'd love to keep going on this line of questioning, but I did promise that we'd get to some of the questions from the audience. So I'm just going to cherry pick a couple, and I think the first one I'll send to you, Avinash. So I'll paraphrase this a bit, but essentially the question is around how will you take on the Chinese brands that have expanded this is in reference to buses, that have expanded very quickly in China and then have approached the European markets as well?
So I think in general, in all markets you see, whether it's consumer electronics, transportation, etc., there is enough space for all brands to exist, or at least the ones that serve the customer needs. So our main focus is on not really worrying about what the competition is doing, but worrying about what we think the end customer, which is the passenger, needs. So if you look at the bus that we announced today, and you look at the way we're doing the seating, the way we're doing the connectivity, the way we're doing the internal ecosystem, the spaciness or airiness of the vehicle, we're taking a very, very focused approach, as I mentioned before, in the experience. Also then talking to the operators about, what are their key pain points. So it's about really listening, paying attention, understanding, what problem you're trying to solve. But I also think that if you look at what we've managed to do is just like we did with the van, it's rethink the whole bus concept. So, I was mentioning this fully flat floor. The way we've done the bus, we have the seats that are cantilevered to the body. So it gives a fully flat floor for you to be able to do your maintenance a lot easier. You don't have little nooks and crannies that you have to get dirt out of and things like that. We have an upgradability built into the bus. So, so as I mentioned, the way we've done the architecture, we can actually change out batteries for more efficient batteries or other power electronics. So it really matters to us, how these buses will be used, what people will experience within them. And then, just to touch on the COVID point, it's also going to be about companies' ability to respond quickly. So I think, the days of, spending, and for those who aren't aware, typically a vehicle program will take somewhere between 3 to 5 years, right? So you're sitting here and you're trying to predict in a typical engineering model what's going to happen 5 years from now. And obviously no one can predict something like COVID was going to happen, for example, right? So I really think it's going to be, for us, when we look at, again, we don't really want to worry about what competitors are doing, but for us, it's very much like, we need to be able to respond very quickly with either changing the design or launching a new update or being very responsive to changing consumer needs. So this whole, spend 5 years engineering, designing a vehicle, and then own it for 15 to 20 years, and then it hasn't changed through that life cycle either. So, you're talking about, you buy a vehicle, and if you do run it to end of life, it's 20 years old even in terms of technology. I think that's gone. So one of the things that we're really focused on with the way we deploy technology is quickly change, quickly update, and you get a lot of that from actually speaking to the people who use your product, both the user and the customer.
Okay, thanks. We've got a question on the availability of raw materials, so specifically cobalt and lithium. And then the question also asks about recycling rates. So I thought I'd throw this to the two sustainability directors, Peter or Asa, who would like to go first.
So I'll go first, and then Asa, you can follow on. So unquestionably, there are still challenges that remain with battery technology. Recycling is not a fully solved problem. It will be, but it isn't yet. That can't stop us from proceeding with what we already know to be the capabilities that this technology has. And one of the things that is interesting is that we talked earlier about energy storage solutions and the potential for that type of technology in conjunction with smart grid and as part of energy buffering solutions. I think we're moving towards a world where once a battery has done a service life in a vehicle and has maybe, let's say, 75, 80% of its capacity remaining, it is still perfectly capable of doing another service life in a building as an energy, as part of an energy storage stack. So we're then talking about doubling the life of the battery, getting maybe 20 years out of a battery. That's a long time that we've got then in which to figure out the recycling solution, which will undoubtedly be solved. So we've got to crack on and take advantage of what we can do now, whilst keeping our eye on the longer term challenges and developing those as we proceed, and putting in place these opportunities that we see with the reuse of assets that are very much part of the circular economy approach to what we're trying to do here.
I totally agree with that, and the recycling part is actually also, of course, part of the business model going forward with the batteries. We are in a partnership with Northvolt, the battery producer, just because of this, and because they have a very clear strategy on the recycling and how to reuse all parts of the batteries, including, of course, also sourcing of minerals from more sustainable places and countries. And this is a fundamental piece of the puzzle going forward, where we see today that today's batteries that we source they would have a CO2 depth actually of up to 3 years when the vehicle starts rolling. So this is super important. Also, how the electricity that you use to produce your battery. So everything from a life cycle and circular perspective is very important.
Great. Johnny, we've got a question around the learning curve of new adopters of a vehicle, and I suppose this applies to electrification and to fuel cell vehicles as well. But how steep has that learning curve been?
And is that for us as an operator or for our drivers?
That's for drivers, I believe.
So for the drivers, I mean, it's been quite interesting to have to teach a driver how to refuel a vehicle. Is obviously something that you wouldn't have ever thought of being in a position to do, but clearly it's a very different, high-tech and quite sensitive hardware compared to what you get at a petrol station or even an EV charging post. But that's a sort of 1 hour training session for 5 drivers, and it's done. And then the other big question that comes with all of this is around range anxiety. I talked earlier about the really impressive range of the Toyota Mirais that we're driving, but because there is a relative lack of refueling stations, you will have the issue that a driver feels they might need to go and refill more often than they would in a petrol car, put it that way. So I think there is that psychological side of it. We've got drivers now who've been driving Mirai for over 3 years, and they're now not only sort of totally used to it and it's second nature. I think as tends to happen with a lot of this technology, they couldn't imagine driving an ICE car or any other vehicle really. So I think there is that curve that then you get to the top of, and actually you've done your learning and you're quite happy, and you then, because it's such early technology in the mass adoption phase at least, you then feel quite excited and proud to be part of that early adoption wave of technology. So I think you go through that sort of the curve, and then the sort of the positive emotions of actually being a bit of an expert in your field, and feeling really proud to be part of something early. So yeah, it's definitely there early on, but of course, the more drivers we have who've been in the cars for a while, who can buddy up to the new drivers, and who by definition vouch for the commercial viability of the vehicle, the less the newer drivers are concerned. So it is there, but it's becoming a smaller issue, I think.
Great. And with the last few minutes, as we finish off, I'll go to the top requested question in the app. Is there, in each of your respective sectors, is there a particular technology that you see will win out or be clearly dominant, or will it end up being quite a mix of different technologies in terms of the drivetrain? So Johnny, you've answered something similar to this earlier on, but perhaps we can go to you first.
So yeah, for me, it really is a mix, and not only a mix because of the use cases differing, whether that's the urban landscape, the journey profile, or whatever it may be, but also the speed of development. I think there will be times where hydrogen makes more sense for us. There may then be times in the future where battery plug-in makes more sense for us. It may then come around again. So there is, so much going on, and it's such a rapidly changing situation as well, that it's not only both, but I think they will sort of be like horses racing against each other, pulling ahead of each other and then back, and what have you. And I'm sure, other technologies may well come into the race that we haven't thought about yet, or that are in a much more nascent stage than hydrogen and plug-in technology are today.
Great. Avinash, I see you nodding in your head. Do you agree?
Yeah, I totally agree. So I think it's going to just be important to be able to be responsive to that. I don't see right now. I mean, we're already in a case where there's certain applications where hydrogen fuel cell is better than batteries, and vice versa. And to Johnny's point, I see a lot of really interesting R&D in even battery technology, fuel cell tanks getting smaller. So yeah, I think this will be a fun race to watch, and I think biofuels, we have to see what happens there as well. So I think it's going to be an interesting 5 to 10 years as this transition happens, I think.
Yeah. And also your view, you mentioned a bit about transition fuels, but in the longer term, does one clear technology win out?
Electrification in some, an electric vehicle then being carrying a battery, but it can be in combination then with different types of charging, including hydrogen. So I think that the future is definitely electric also for heavy duty transport. But then if we're going to see a more charging point or dynamic charging, I think the advantages with dynamic charging are actually huge, but it's also a system solution. So it will have to be implemented as a system where you need some political intervention to make that kind of thing happen. And that is also the challenge with that system. But yeah, that has a great potential.
Great. And Peter, from your perspective?
I agree with everything that's been said. We are headed towards a zero emission future, which implies some form of electrification. I agree that hydrogen is one way of providing that electric solution. And I think hydrogen will have a role in the future economy, for sure, in, for example, heat. I'm frankly a little bit skeptical of hydrogen's role in transport, simply because of the efficiency challenges that it faces, the amount of energy that's required to let's say, electrolyze water to create hydrogen and then reconvert it through a fuel cell. The losses are substantial compared to a pure electric solution, and that has to be brought back somewhere. You have to make up for that with some other benefits, and the rate of progress with pure electric now in terms of battery technologies and the potential for catenary supplies is so great I'm not sure hydrogen is going to catch up, but we remain open-minded and in the meantime pursue the electric solutions that we're able to pursue with full speed.
Wonderful. Thank you, Peter. We're going to have to leave it there as we're out of time. I'll thank you all for joining me, and everybody that's listening in, thank you for joining all of us. Cormac, I'll throw it back to you now.
Thanks very much, everyone. Really great to have such a lively debate. And thank you so much to our panelists and to Andrew as well for steering us through that. Just did want to mention we have some very interesting webinars also upcoming. Obviously following in the footsteps of some great thoughts there. But this time next week we will have autonomous vehicles, the big update. And then the following week, we have Autonomous Industry Futures that will be at midnight British Standard Time. We're going to be bringing together a Japanese-based and a California-based speaker on that one. So do keep an eye out for our updates there. Thank you very much and look forward to seeing you all again.